Here's problem number 35 from section 3.1. It asks us to look at the idea of a derivative to determine whether the idea of two parabolas being parallel. We might think of parallel as meaning equal slopes, or at least equal, in this case, equal derivatives. So what if we had a function f of x is equal to x squared? What is its derivative function? Well, its derivative is going to be the limit as h approaches 0 of f of x plus h minus f of x over h, or the limit as h approaches 0 of x plus h squared minus x squared over h, which is equal to the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. Those x squareds cancel. The remaining terms have a common h in them, which I'll factor out, but not before I write the word limit. Limit as h approaches 0 of h times 2x plus h over h. These h's cancel, and that gets me the derivative 2x. Now, that is the derivative for the standard parabola. Now, are there any other parabolas that have that same slope function? And the answer is g of x squared plus 2, for example. If I took its derivative, I get the same value. In fact, I might say that I don't even need to have a value there. I could just say a, where a does not equal to 0, and f and g are parallel. Or at least for every single same point, they end up having the same slope. Now, does that make them equidistant? Well, if we take a look at the graph of get a new graphing window up. If we take a look at the graph add a page graph, and we say x squared, and again we'll use the example x squared plus 2, we can see that these two graphs, they don't seem to be equidistant. I mean, there's a distance of 2 here, but certainly not a distance of 2 at their closest points. Now, is there a difference of 2? Well, actually there is. If you go from here to there, let me probably be better if I draw this out. Here's graph 1, here's graph 2, and they're getting tighter here, but always there's a distance of 2 between those. So 2 here, 2 here. So there is an equidistance if you measure them in the right orientation.